Chapter 7, Section 4, More Multiplication Properties of Exponents. When we're raising a power to a power, to raise a power to a power, you are going to multiply the exponents. When you are raising a power to a power, your problem will look like this. You're going to have any power inside of parentheses. In this case, I have 2 cubed. And then right outside of the parentheses, you're going to have another exponent or raising it to another power. You are always going to have parentheses when you are raising a power to a power. So in this case, I have 2 cubed to the 5th power. So I would multiply 3 times 5. My base is going to stay the same, so I would have 2 to the 15th power. What is the simplified form of b cubed to the 5th power? Notice here I have parentheses inside, I have b cubed inside of parentheses and then right outside to the 5th power. So my base b is going to stay the same, and I'm going to multiply the two exponents, 3 times 5. Well, 3 times 5 is 15, so my final answer would be b to the 15th power. This next example says, what is the simplified form of h to the negative second, in parentheses h to the 4th, and then right outside of the parentheses to the negative 3rd? The first thing I need to do here, first notice that h to the negative second is not raised to a power. It's just kind of outside being multiplied by h to the 4th raised to the negative 3rd power. So what I need to do is I need to raise my power to a power first, or h to the 4th to the negative 3rd, by multiplying 4 times negative 3. My h to the negative second is just going to be brought down for now. It's still there, but I'm not ready to combine anything yet. So next I need to do 4 times negative 3, which is h to the negative 12th. So I have h to the negative second times h to the negative 12th. Right now I'm just multiplying two powers with the same base h. So I'm going to use my exponent rules that I learned yesterday, and I'm going to add my two powers together, which would give me h to the negative second plus the negative 12. Add them together, you get h to the negative 14th, but we're not happy when we have a negative exponent. We need to write it as a positive exponent, so we put it under 1. So our final answer is 1 over h to the 14th power. Raising a product to a power. To raise a product to a power, you're going to raise each factor to the power. Remember, the factors are the different things that you are multiplying together. When you are raising a product to a power, your problem is going to look like this. Notice now inside of parentheses, I have a product or a multiplication problem, and then right outside of the parentheses, I'm going to have it raised to a power. Again, just like with the power to a power, for a product to a power, you're always going to have parentheses. What you're going to do here is you're going to take your exponent that's on the outside and you're going to distribute it into each factor, multiplying the power that's already there times the power that's on the outside of the parentheses. So an example of this, it says, which expression represents the area of a square? Notice that we're told that one side of the square is 4x to the 5th power. Remember, to find the area of a square, you can take the sides and you can square it. So a side length of 4x to the 5th power, we're going to go ahead and square that to find the area. Notice my two factors here would be 4 and then times x to the 5th. For 4, there's an understood exponent of 1, so I'm going to bring that in, and I would multiply the 1 that's there times 2, which would give me 4 squared, and then I also need to multiply the exponent for the x, which is 5, times 2, which would give me 4 squared times x to the 10th power. When you have a constant that's being raised to a power, in this case I have 4 squared, I need to go ahead and do that and simplify that before I find my final answer. So I'm not quite done yet. I need to do 4 squared, which is 4 times 4, which is 16. And then there's nothing that I can simplify with x to the 10th. I have a positive exponent, so I'm good. So my final answer would be C, 16x to the positive 10th power. This next example says, what is the simplified form of b to the sixth raised to the third power? And then in parentheses, I have 8a b to the negative fourth. And then right outside of my parentheses, I am squaring that whole thing. So what I need to do first is I need to go ahead and take my exponents that are on the outside of my parentheses and distribute them in to the inside. So for b to the sixth, I would need to multiply 6 times 3. So b to the 6 times 3. And then for the second product to a power, I'm going to need to distribute this 2 in to all 3 exponents that are there, multiplying each time. So b to the 6 times 3 would be b to the 18th. And then 8 to the 1 times 2 would be 8 squared, a squared, and then b to the negative 8th. Notice now I have like terms. I have a b to the 18th, and then I also have a b to the negative 8th. The only operation that I'm doing with all of these values is multiplying them. So I can go ahead and I can combine them. And I'm also going to go ahead and do 8 squared. 8 squared is 64. And then a squared stays the same. There's nothing that I can combine them with. And then it would be b to the 18th plus negative 8. Well, 18 plus negative 8 is 10. So my final answer would be 64a squared b to the 10th. This next example says the formula for volume of a sphere is v equals 4 over 3 pi r cubed, where r is the radius. What is the volume of a sphere with a radius of 10 squared millimeters? Give your answer in terms of pi. First thing I need to do is go ahead and plug in 10 squared for the radius. Notice that I have a power to a power, 10 squared raised to the third power. Right now I'm just going to keep bringing down 4/3 and then times pi. So when I multiply 2 times 3, I would get 10 to the 6th power. Well, 10 to the 6th power is written as 1 million. Then I can go ahead and I can combine. I can multiply 1 million times 4/3, which would give me the 4 million over 3. And then pi millimeters cubed would be my volume. Today's assignment is on page 464, numbers 1 through 9, and 10 through 48 even.